So today we are going over the review sheet. We're going to go on and get started going over the review sheet. Now, I know that there's the possibility that of inclement weather over the next few days. Hopefully we're here tomorrow. The test, so if we're here tomorrow, your test is tomorrow. If we're not here tomorrow, your test is the next day that we are here. So the next day that we're here is going to be your test. Then your test will be Monday. Yep. Yep. All right, guys. So. All right. So the test will be the next, either tomorrow or the next day that we are in person. If we end up not being here due to inclement weather tomorrow. Now, I've also attached 3 videos that are going through every single problem of this review sheet in Google Classroom. So if we're not here tomorrow and you wanted to go through some of the ones we didn't cover or wanted to see them again, those are posted there. Yes. It is a pie tie. Yes, sir. It's for 2/2 Tuesday, because today's date is 2-22-22. And it's Tuesday. So 2/2 Tuesday, or tie Tuesday. Now, we're going to go on and start with these here with direct and inverse variation. Or neither, is what we're trying to determine with these here. Now, the direct variations equation was y is equal to a times x. If an equation comes in this form, we know that it's going to be direct variation. Now, realistically, x and y don't make a whole big of difference, because it could also be x is equal to a times y. They're the exact same thing. Now, if we wanted to, we could get a by itself for here, dividing both sides by x, telling us a is equal to y over x. Or we could also say a is equal to x over y. And they're just the different general forms of the equation that we could have. Now, the other type that we have is inverse variation. And kind of the general form for inverse variation is y is equal to a over x. I mean, we could also say that x is equal to a over y, because we're just comparing these variables. For direct variation, they're both increasing or both decreasing. In inverse, one is increasing as the other one decreases. And if we got a by itself for here, we would get a is equal to x times y. Now, for that one there, we really don't have 2 different forms, because, I mean, even if we switch the variables, it's still x times y or y times x. It doesn't give us something different. But these here are kind of the general versions for both of these sets of equations here. So looking at number 1, it would be direct. Number 2 would be because the first one matches up to one of our direct versions of the equation. Number 2 would match up to our inverse. Number 3, neither or neither. Number 4 would be inverse. So that means 5 is inverse, yes. And lastly, number 6 is neither. And one big giveaway for neither is addition or subtraction. Because for it to be direct or inverse, we're really dealing with multiplication or division. We don't have any addition or subtraction. Any other questions on these first 6? Okay. 7, 8, 9 is not on the test. Yep. just time's sake and trying to put those together. Yep. Let's look at number 10 next. For 10, 11, 12, and 13, when we're simplifying, we need to factor the numerator and denominator as far as we possibly can and then simplify. Well, with number 10, the numerator, 2x squared can't simplify any farther than what it is because it's a single term, so there's no way we can simplify it. The denominator has two terms. And we can do that because it has a greatest common factor of x that we can pull out. And once we pull that out, well, we do have a common factor of x on top and bottom. So yes, the numerator would become 2x, and the denominator would be 3x minus 4. And that's as far as it goes, because the 3x minus 4 is stuck together with that subtraction sign, so we can't do any simplifying there. And that's it. That's all we have to do for this one here. Huh? Right, we can list the restrictions, and it would just, if it doesn't ask for it, I'm not going to mark off for it. I listed the restrictions in the key for the answer key on all of them, just so that y'all would have them. But it just says simplify each expression if possible. If it doesn't ask for it, I'm not grading for it. All right? So the restrictions for this here, according to the textbook, would be x cannot equal 0, because that's the only one that's simplified out of the denominator. Our other restriction for this here would be 4/3, because the 3x minus 4, well, I would add the 4 and then divide by 3, which would give us 4/3. And that's all we would need to do for this one here. Any other questions on number 10? The next one we'll look at is 13. I'm not putting a factoring by grouping or factoring by sum or difference of perfect cubes. So neither one of those will show up on the test. We won't have, because that's a difference of perfect cubes. Now 13, we do need to factor the numerator and denominator to see if there are any like terms. I would always start with the one that we find easier to factor between the two. For these here, it looks like it'd be easier to factor the denominator, or x squared minus 4, because that's a difference of perfect squares, which would be x plus 2 and x minus 2. So, if this does simplify in some way, shape, or form, we need the numerator to either have an x plus 2 or x minus 2. It kind of gives us a guide to what to look for. Since the 12 is negative, our signs are opposite. Well, the factors of x squared are x and x. The factors of 12 are 1 and 12, 2 and 6, or 3 and 4. 2 and 6. And we actually want the 2 to be positive. And if we check this here, x times negative 6 is negative 6x, plus 2 times x is 2x, which does give us a negative 4x that we wanted. Any questions on this here? Well, now we can cancel out the like terms on top and bottom, which are x plus 2 and x plus 2, leaving us with x minus 6 over x minus 2. Thank you. And that's all we have to do for this here. Well, not with that denominator. The x cubed minus 27. No cubes that you'll have to factor. Because I'll go back through and make sure, because I believe I checked this morning, make sure that they weren't. If it, for some reason, one does pop up, I will give it to you. I'll actually write out what it is factored so that you don't have to try to do that on your own. because I know that y'all can do them, but at this point, I've set it to the other 2 hours, so I'm going to give it to you if it does show up. Okay. Any other questions with simplifying? All right. Let's look at number 15. With multiplication and division, the main thing that we need to do is factor all of them, all the terms before we cancel. Well, the x minus 1 and 2x are as simplified as they get. The 2x, because that's the only term. The x minus 1, even though it is two terms, they don't have a greatest common factor, and the degree is 1. So there's nothing we can do with these two here. So we can look at the numerators. And the first numerator is x squared minus 4x. Well, x squared and 4x do have a greatest common factor of x that we can factor out. And if I factor an x out of x squared, well, we're left with an x minus 4. Because if I take the x away from 4x, we're just left with 4. And it stays minus because we're not messing with the signs. Now for the x squared plus 3x minus 4, well, we'll need two sets of parentheses, and we would have opposite signs. Now we would normally check for greatest common factor, and I think at this point, when we look at it, we can see that x squared, 3x, and 4, there isn't a greatest common factor, because 1, 3, and 4 won't have it. Then we have our signs, and factors of x squared are x and. Now we need to look at the factors of 4 that we want, either 1 and 4 or 2 and 2. Well, it'd be nice if the 1 was negative, because if it is, I have an x minus 1 on top and bottom, which would mean that the 4 has to be positive. And if we do check this, we would get negative x plus 4x, which is positive 3x. That's the middle term that we wanted. Any questions on this here? Now, when we multiply these together, we do have some things in common. The x minus 1 and x minus 1. We also have the x and x would cancel. So in the numerator, we're left with x minus 4 times, and the denominator is actually 2. It was pointed out to me first hour that the answer key does have that wrong. I, for some reason, dropped the 2 out, forgot to write it back in. So this here is the correct answer. It does need to be divided by 2. Any other questions on this here? Y'all want to look at 16 or 17? 16. So we look at 16, we're going to be factoring first. Since it's multiplication, we're going to go on and factor what we can. And I always try to start out with the first, or one of the ones that I think would be the easiest to factor, because then we can try to match up like terms in the factors of the others. Which one of these do we think would be easiest to start with? Because it has a greatest common factor of 2x. And if I factor 2x out of 2x squared, we're left with x plus 2. Because 2x out of 4x would leave us with 2. Any questions on this here? Now at this point here, we can try any of these here. We can just go to the denominator. The x squared minus 4x plus 3. Since the 3 is positive, the signs are the same and they match the sign of the middle term, so we would have negative and negative. Well, that tells us neither one of these is going to be x plus 2, because they're both minus. Also, so x squared would be x and x. And the factors of 3 don't include 2. or just 1 and 3. And that there's actually the correct set of factors. And if we checked it, we would see that we would get a negative 4x. We'll need to factor the other two anyways. We can start with the numerator. The x squared plus 3x minus 4. Since the 4 is negative, our signs are opposite. One's going to be positive, one's going to be negative. Well, the factors of x squared are x and x. And the factors of 4 are 1 and 4 or 2 and 2. Well, since the 3 is positive, we would want the 4 to be positive and the 1 to be negative. But also with an x minus 1, we do have 1 in common on top and bottom now, so that is also helpful. Now, brings us to the last one. Since the 4 is positive, the signs are the same and match the sign of the middle term, and we're talking about the constant term 4. So we would have, for x squared, we would want x and x. Unfortunately, we're not going to have 1 and 4, but 2 and 2. Because if we did 4 and 1, we would actually get a middle term of 5x, because they would add together. But we would want 2 and 2. So sometimes, especially with these here, it's good to go on and check it to make sure we do get the correct middle term. Now at this point here, since we do have everything factored, our numerators and denominators will multiply together, and we can cancel out what's in common on top and bottom. So our x minus 1 and x minus 1 would cancel. We'd also have that the x plus 2 and x plus 2 would cancel, leaving us with our 2x times x plus 4 in the numerator. The denominator would be x plus 2 times x minus 3. And that's it. Any questions on this here? We good with 16? All right. If we're good with 16, we'll go on and look at 19. Now, the only main difference with 16 and 19 is that we're dividing. And whenever we're dividing two fractions, we change it from division to and flip the second. Now, if you feel comfortable with doing this, you could factor and change it from division to multiplication and flip. But you need to make sure that we do flip when you factor, if you do that all at once. Because it is very easy to just write the factors down and not flip the second. Because when we flip the second, the numerator is going to be our x squared plus 12x plus 20. And the denominator is going to become our x squared plus 13x plus 40. And really, once we change it from division to multiplication, everything else is the exact same as what we just did. There's no real difference. Now, we do need to factor all 4 of these here. Now, unfortunately, unlike some of the ones we've had previous, we don't have one that's just easy to look at, like a difference of perfect squares. So we just really need to pick a place to start and go from there. Well, if we start out with the x squared minus 3x minus 40, well, the negative 40 tells me the signs are opposite. One's going to be positive, one's going to be negative. Our signs for x squared are going to be x and x. And our factors of 40 that we want to use, well, 1 and 40, 2 and 10, 3 doesn't work, 4, 5 and 8. And we would want the 5 positive and the 8 is negative. Because negative 8 plus 5 is negative 3. Now, if we look at the denominator, since the 20 is negative, our signs are going to be opposite. One's going to be positive, one is negative. Factors of x squared are x and x. Now we need to look at the factors of 20 that we want. So we have 1 and 20, 2 and 10, and 4 and 5. It's going to be 2 and 10. And the 10 would be positive and the 2 is negative. It'd be very tempting to want to use 4 and 5. But no matter how we set it up, if we had the 5 positive and the 4 negative, our middle term would be x. If we flipped it, we would get negative x. So 4 and 5 doesn't work for that denominator. That just tells me that, well, there's no like terms in the first rational expression. So we're looking for like terms in the second one. Now, if we look at the numerator, x squared plus 12x plus 20, well, we're going to have plus and plus. Factors of x squared are, and it's 2 and 10 again, because 10 plus 2 does give us 12. Now the denominator, since the 40 is positive, our signs are the same and match the sign of middle term, so we actually have plus and plus. X squared would be x and x. So the factors that we want actually work out to be 5 and 8. Because 5 plus 8 does give us 13. Any questions on this here? Okay. Now when we multiply these together, really we're just putting all the numerators multiplied together in the same fraction. So rewriting them as that doesn't really change anything. We can go on and simplify at this point here. Well, the x plus 10 and x plus 10 will cancel out. The x plus 5 and x plus 5 will cancel, leaving us with x minus 8 times x plus 2 over x minus 2 times x plus 8. And that there's as simplified as it gets. If one of the x's had been negative, then we could look at probably factoring a negative out. But that's only going to really work is if the two terms, like here, the negative 8 minus x, if we had negative x minus 8, then we could factor a negative out to get it to match up. But both signs have to be opposite. The x's and the number both have to have opposite signs. Then we could factor a negative out to get them to cancel. But this one here, that's as far as we can take it. Any questions on this here? Let's look at the next problem. Number 21. We're looking at addition and subtraction. Now the only way we can add or subtract rational expressions is if the denominators are all the same. Well, luckily for us here, all three of these have a 3x plus 2 as their denominator. And also, since it's all plus, we can kind of go on and add them together because we don't have to worry too much about the signs with subtraction. Because we can just go on and add the numerators. Well, 9x squared doesn't have any other like terms. We can add the 6x and 6x, which would give us plus 12x. And lastly, we have negative 1 plus 5, which is plus 4. And we get to this point here. Now, before we can officially say that we're done, we need to make sure that if the numerator does factor, that it wouldn't have anything in common on top and bottom. So, I mean, if the x squared term did have factors of 3x and the constant term 4 did have factors of 2, then most likely there's probably going to be something that lines up. Well, okay, we actually do have that. Because plus 2. Because if we look at this here, well, since the 4 is positive, the signs are the same and match the sign of the middle term. Okay, we do have hopefully one that will match up. the factors of 9x squared, well, we will have x and x, and we would need one of them to be a 3, yes? That means the other factor has to be a 3. Because factors of 9 are 1 and 9, or 3 and 3. Well, the factors of 4 are 1 and 4, or 2 and 2. And if we did check this, 3x times 2 is 6x, plus 2 times 3x is 6x, which does give us a middle term of 12x. So it does factor to 3x plus 2 times 3x plus 2. Well, one of these will cancel, telling us that we have an answer of 3x plus 2. Now, the denominator did simplify to 1, so we don't have to rewrite it back in because it is 1. But if it was in the numerator it simplified to 1, then we need something still in the denominator. If the numerator is 1, we do still have to write it as 1. If the denominator is 1, we don't have to include it. Any other questions on this one here? Or anything we've done thus far? Okay. 21. All right, we'll go on and look at 22 next. Now again, when we don't have like denominators, it will be good to factor all the ones that we can so that we can see what we need to do to make them be the same. Now we don't touch the numerators for factoring. Now x squared minus 5 doesn't factor. Now if it did, if it was x squared minus 4, we still wouldn't factor it. Because again, if they're like terms in the two numerators, we still need to be able to add or subtract. So if we did factor it, and if it was factorable, well then we would have to undo that, distribute it back out for us to actually be able to add and subtract the like terms. So the only ones with addition and subtraction that we look at factoring are the denominators. So we're looking at the x squared plus 5x minus 14. Now it'd be really nice if one of them was x plus 7. Because then we'd have at least one in common in the denominator, so we have less to actually multiply. Well, if we factor this, since the 14 is negative, our signs would be opposite. The factors of x squared are x and x. And well, the factors of 14 are 1 and 14 or 2 and 7. 7 and 2. And if we checked it, we would get 7x minus 2x, which would give us a positive 5x, which is the middle term that we want. So that is good. Because when we're trying to get them to be the same, well, does the one on the left have everything that the one on the right does? Well, yeah, they both have an x plus 7, yes? The only thing that's missing is the one on the right is missing an x minus 2. So really, I just need to change one of them. One of them already has everything. The other is just missing a part. Now these here we do need to be careful with because of the subtraction. Because that negative, that subtraction, is going to apply to everything in the numerator of the second expression. So we do need to be careful there. Now we can go on and distribute across the top. X times x would give us x squared. X times negative 2 would be negative 2x. 3 times x is going to be plus 3x, and 3 times negative 2 would be negative 6. Now I don't have to worry about changing the signs yet because, well, we haven't combined or actually subtracted the two numerators yet. Now, if you felt comfortable, you could go on and subtract the numerators at this point here, do x squared minus x squared, and then subtract the x's and do all that there. But if you don't, that's perfectly fine, because it's a lot going on. Because what we could do at this point is just say x squared minus 5, minus. Because the x squared minus 5, there's nothing that we're changing the sign with that. But the one that we are subtracting is our x squared, negative 2 plus 3x, plus x minus 6. So we can write it as 1 with the second set of terms in parentheses. So that when we apply that negative, we can see that we get negative x squared minus x plus 6. Any questions on this here? Now we do have some x squared terms, so there's a chance we'll have to factor, yes? But let's combine like terms first. X squared minus x squared. Well, these will simplify out, because x squared minus x squared is 0. Well, our negative x doesn't have any other like term, so it's just negative x. Negative 5 plus 6 is plus 1 over plus 7 times x minus 2. So we do have the negative x plus 1 in the numerator. We can factor that negative out, which would just leave us with x minus 1. Well, do we have an x minus 1 in the denominator? Well, no, we have an x plus 7 and x minus 2, yes? Well, that won't simplify. So really, that's it. Because we could have factored it out, which would have just told us we have negative x minus 1 over 7 times x minus 2. Well, nothing simplifies, so we can leave it as is. Any other questions on this here? We good with this one here? All right, let's look at 26. Finding the least common multiple for each problem. When we find the least common multiple, we're trying to see what we need to make both of them be, like what we did for the last one to get the denominators to be the same. So for this here, we'll factor each of the sets of terms as far as they possibly can go so that we can match them up. Now the 2x squared is one term. There's nothing we can do to it. So it's just going to say 2x squared. But the 4x plus 12, we can factor out a 4, giving us 4 times x plus 3. Well, that's actually as far as we can take it. So now we can actually find the least common multiple. Well, I know I'm going to need an x plus 3. It shows up in one of the terms, so we need it. What other variables do we need? Well, we'll need a 4, actually. But we'll also need the x squared. Because it works out that 4 is the smallest number I can turn both 2 and 4 into. So it would be the least common multiple for 2 and 4. Since the first term has x squared, we would also need it. And that's actually all we would need to do for this here. Any questions on this here? We're also going to look at 29. Now, number 29, we do need to factor these as far as we possibly can. So looking at 29's 4x squared minus 16, well, they do have a greatest common factor of 4. And if I factor a 4 out of 4x squared, we're left with x squared. And if I factor a 4 out of 16, I'm left with 4. Lose your review sheet. Okay. Well, someone's missing an answer key. You can follow through with that. Now, The x squared minus 4 is a difference of perfect squares. So we would have x minus 2 and x plus 2. Need that extra bit. But that is as far as that goes, because each one of the sets of parentheses does have a degree of 1, and it's as simplified as it gets. Now, if we look at the other one, 6x squared minus 24x plus 24, there is a greatest common factor of 6. And if we factor it out, we're left with x squared minus 4x plus 4. So looking at greatest common factors is one of the big things we need to do first. Now, when we factor x squared minus 4x plus 4, well, since the 4 is positive, our signs are the same and they match the sign of the middle term, minus and minus. Factors of x squared are x, and the factors of 4 that we want are 2 and 2. Now, we are going to have to look at the 4 and 6, but I really like looking at the sets of parentheses first because they're a little bit easier to find for least common multiple. I know for sure I'm going to need at least an x minus 2 and x plus 2, because both of those do show up at least once in all of the terms, yes? So we need any other sets of parentheses. We'll need an x minus 2, because here x minus 2 shows up once, so we need it once. Here it actually shows up twice. Since x minus 2 shows up twice in one of the two terms, we need it twice. Even though it does show up once here, since it shows up twice here, we need it twice. Here, an x plus 2 shows up once. It doesn't show up in the other, so we need it once, because we need it whichever term has it the most times, which is twice for the x minus 2 and once for the x plus 2. Well, now we need to see what number we can turn both 4 and 6 into. Exactly, 12. So 12 times x minus 2 times x plus 2 times x minus 2 would be the correct answer. And as long as we have those, especially the x minus 2, x plus 2, and x minus 2, doesn't matter what order, as long as we have the x minus 2 twice and the x plus 2 once, that is perfectly fine. Any other questions on this here? All right. I want to look at 38. If we have time to look at one more than 38, we will or can. If not, I want to look at least at this one here. Whenever we're solving, two of the first things that we want to do is, one, make sure all the denominators are factored, and secondly, look for restrictions. I think that this is actually negative, yes? Yeah. We do need it to be negative. I did not switch it over on the note sheets for here. Now the numerator or denominator that we do need to factor is this one here. And it works out that we have x plus 3 times x minus 2. So that is telling me that x cannot be negative 3 or 2, because if x is negative 3 or 2, one of those denominators would be 0. That doesn't work. Oh, okay. We can multiply each of these by our x plus 3 times x minus 2. I realistically just grab the denominator of that first term. And let's see what cancels. On the first one, the x plus 3, x plus 3, x minus 2 and x minus 2 cancels. That's nice. The 2 in the middle, well, it doesn't have a denominator, so nothing's going to cancel. And the last one, the x minus 2 and x minus 2 cancel. So did all the denominators cancel out? Well, yes, so we're good. And a lot of the times it can sometimes be helpful to just pick one of the denominators and multiply through and see what we get. If all the denominators canceled out, we're good to go. We can move on. If one of them didn't, we can add it to all the terms being multiplied and then simplify from there. Now, when we do that multiplication, well, the negative 5 is by itself because everything else simplified. The middle term, we have 2 times, well, x plus 3 times x minus 2 came from our x squared plus x minus 6 plus x minus 3 times x plus 3. Well, we'll do that. Where is it? Like this at negative 5. At this point here, we can distribute the 2 through. 2 times x squared would be 2x squared. 2 times x would be 2x. And 2 times negative 6 would be negative 12. Now the next part, the x plus 3 times x minus 3, you all know what that would factor to? X squared minus 9. X plus 3 times x minus 3 is our difference of perfect squares factored, so they'll multiply back together. If y'all went on and multiplied that out, the 3x and 3x that we'd get in the middle would cancel out. Now we just need to combine like terms. So negative 5 is equal to x squared plus 2x squared plus x squared is 3x squared. Plus our 2x minus 21. Stick with me and let me finish this here, and then we'll be done, because we have a few less steps to finish this out. Yep, I will call him. We can add 5 to both sides, which gives us our 0 is equal to 3x squared plus 2x minus 16. Now we can graph this one here, but there's a good chance we're going to get fractional answers because of the 3x squared. Now, because 16 is negative, our signs would be opposite. We'll end up getting 3x and x, and it works out the factors of 16 we want are 8 and 2. Now, because we have two things multiplied together to equal 0, one of them must be 0, either the 3x plus 8 or the x minus 2. For this one here, we can subtract 8 from both sides. Gives us 3x equals negative 8. Divide both sides by 3, telling us x is equal to negative 8 thirds. For the other side, well, we would add 2 to both sides, telling us x is equal to 2. But that's one of our restrictions, so it doesn't work. So the only answer is negative 8 thirds. And that's all we'd have to do for this one here. So if you want to see some of the other ones done, I did attach videos into Google Classroom that go over all of them. So you have those there. So your test is tomorrow or the next day that we are here.